Welcome to our discussion of patterns in mathematics. In this module, we will discuss what mathematics is, explain the relationship between inductive reasoning and patterns, give some examples of different types of patterns, define sequence, use finite differences to find the next number in a sequence, determine if a sequence is arithmetic, geometric, or neither. Determine the common difference or ratio if there is one. And describe visual patterns verbally and numerically to determine the different sequence terms. What is mathematics? Complete the sentence with words or phrases. To me, mathematics is. What do these three gifts have in common? So they're all babies eating a lemon, and none of them seems to like it, and they make adorably ugly faces. So then the question is, what does this have to do with mathematics? Mathematics is the study of patterns and relationships. Mathematicians do three things. They notice what is changing and staying the same in a pattern or relationship. They describe that change in patterns, words, or diagrams. They generalize the pattern using mathematical language like algebra, and we'll get to that later in the semester. For now, we want to notice patterns and describe them. So when we noticed that the three babies made funny faces after tasting a lemon, we were mathematicians. What are some types of patterns? So there are patterns in nature, including divisions and spiral in a chambered nautilus shell, like the one shown, or in the branching of a tree. There are number patterns, including things like even numbers and perfect squares. And patterns can also be pictorial with shapes or blocks. Finding a pattern is inductive reasoning, which can be uncertain, as we discussed in our last section. For example, consider the sequence 1, 2, 4. What do you think the next number is? You might say 8, because the numbers appear to double. 1 times 2 is 2, 2 times 2 is 4, and so 4 times 2 is 8. But is that the only answer? You could also say it's 7, because the numbers are being added to. So 1 plus 1 is 2, 2 plus 2 is 4, and 4 plus 3 would be 7. So the pattern by itself is uncertain. There's two possible answers. What is a sequence? So a sequence is an ordered list, usually of numbers, but it could be a sequence of steps to make a sandwich or write a computer program. The sequence of perfect squares shown here has the first through fifth terms marked. Those are the numbers 1, 4, 9, 16, 25. The ellipses at the end means it goes on forever and it's infinite. Sequences can be repeating or growing. Repeating sequences repeat like the sequence 1, 2, 3, 1, 2, 3. Think about repeating decimals, like 1/3 is 0.33333, continuing on forever. Growing sequences grow, like the sequence 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. It has a repetition, but it also adds to it. There are many types of sequences. Two are arithmetic and geometric. In arithmetic sequences, each new number is obtained by adding a common difference. An example would be the sequence 2, 5, 8, where 3 is added to get the next number. So that is the common difference. Arithmetic sequences are like skip counting and linear equations. In geometric sequences, each number is obtained by multiplying by a common ratio. For example, in the sequence 2, 6, 18, You get the next number by multiplying by 3. 3 is the common ratio since 6 divided by 2 is 3 and 18 divided by 6 is 3. You might think of these as doubling, tripling, halving, etc. And they are also exponential. Finding the difference between consecutive terms in a sequence is called finite differences. If the first differences are equal, the sequence is arithmetic or linear. Here's an example. Each of those numbers differs by 5, so I can add 5 to get the next number. If the second differences are equal, the sequence is quadratic. Here's an example. The perfect squares, 1, 4, 9, 16, 25. The first differences are 3, 5, 7, 9, which are not equal, but the second layer at the bottom is the differences are 2, 2, 2. Now you don't have to know that that's quadratic. I just think it's really interesting because the pattern continues. If the third differences are equal, it's cubic. On your homework, you probably won't go past the second layer. There might be one that you go all the way to the third differences, but again, you don't have to know that it's quadratic or cubic. It is possible that they aren't ever equal, and then we'll move on and try something else like ratios. Here's another example. Consider the sequence 0, 3, 8, 15, 24. Find a pattern and determine the next term. If we look, the first differences are already written, and the second differences are all the same, they're 2. Assuming the pattern of 2's continues, the next number after 9 is 11, since 9 plus 2 is 11. Then we add up, 11 plus 24 would give us 35. For each sequence, determine if it's arithmetic, geometric, or neither. Then tell the common difference or ratio if it has one. And last, tell the next two terms. So in the first sequence on the left, I'm going to do the first differences. And they're really different, so I'm going to try ratios instead. Ratios means we're going to divide. So I do 8 divided by 2 is 4. 32 divided by 8 is 4. And if I did 128 divided by 32, it would also be 4. So to get the next number, I'm not going to add, I'm going to multiply by 4 to get 512. That means this is a geometric sequence, and its common ratio is 4. That's the number I multiply by to get the next one. In the middle sequence, I do the first differences and notice that they aren't the same, but they're really close. So I went ahead and did the second differences, and they are all different by 2. So I added back. 9 plus 2 is 11, and 25 plus 11 is 36. Now, because I had to go to second differences to get the same number, that means this is neither. It is not geometric. It is not arithmetic. There is not technically a common difference. In the last one, I did the first differences, and they're all 12. So I added 79 and 12 to get 91, 91 and 12 to get 103. That means this is an arithmetic sequence, and 12 is my common difference. Many times we have a visual pattern to analyze. Here we want to know the number of matches in 60 squares. So you might think 4 times 60 is 240. However, some of the squares share a side. So I'm going to break it down farther. The first square has 4 matches. But the next one only has 3. And the one next to it only takes 3 more matches. And the one next to it only takes 3 more matches. So each time there's a 4, but then I'm only adding 3 more. So if I want 60 squares, I'm going to have 1 4 for the first square and 59 3s for the remaining number of squares. That comes out to 181 matches. Okay, figurate numbers receive their name from the number of dots in geometric figures. They could be triangles, squares, pentagons, rectangles, oblongs, which are long rectangles. And these are the first 5 triangular numbers. You can see they make a triangle. And I want to know what the next triangular number is. So there's lots of ways to get to this, but I think most of you would probably notice that each layer is the number 1, then 1, 2, then 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. I color-coded them for you. So I guess that the triangle has a base of 6, the next triangle. I also notice, if I do finite differences, that they differ by consecutive numbers, 2, 3, 4, 5. So I think I'll add 6 to get the next one, which would make it 21. In conclusion, learning to recognize and describe patterns using inductive reasoning is a major part of mathematics. Patterns can be numerical or pictorial, finite or infinite, repeating or growing. Sequences or ordered list. Arithmetic and geometric sequences are two types we need to be able to identify. We can use finite differences to help us with that. When we have pictorial or block patterns, it helps to describe the change in words, then with numbers, and later we'll get to algebra. Thank you.